Right, we should be live on LinkedIn and Facebook, and we will put the recording later on YouTube. But for now, let's get started.
Hi, Jens.
Hello, Daniela. Welcome to our little interview about Meeting C++ 2024 and your talk and what you're doing, what you're about to do, and anything with C++. So for those who don't know you or generally haven't kept up to date, what are you doing currently in C++?
What I'm doing in C++? Well, as a member of the C++ committee, I'm mostly involved in the language side of things, and I'm really looking forward to C++ 26. As it turns out, the current prospect looks like it will be a really big version of C++ with many new features. Much of it is at compile time. So this affects translation and how we think about our code and how we structure our code. And besides this, what is actually called reflection, we also have many, many other new features which would make C++ more safe. Safety is a huge problem, and in particular language safety. And we are looking very deep into what's going on there, what we can do without breaking all the existing code from the past 30 years or even longer. And so this is the stuff that I'm mostly actually working on right now. But I'm also in my daily work more involved into developing machines at the company where I'm actually employed at. And in the past 15 years, I've been developing a quality inspection system that is, for the most part, made for the inspection of wheel axles in railway systems. Many high-speed trains in Europe are running on wheel axles that are inspected by our machines. And this is the introduction into the company where I'm employed right now. This machine is really a baby of mine, I would say. Of the whole software, the control, everything in there is made by me. Together with my colleagues, we have to also the mechanical construction, the electrical construction, and all the subsystems that need to be there to be usable at a factory floor. And this is where I'm getting my money from developing C++.
Yes.
And I'm still doing it with a lot of fun, to be precise, because over the course of 15 years, I could actually improve the code over the course of C++ 03 now to C++ 23, and growing the source code with new features without actually increasing the size of the code. This is something that I totally like, and this is what's keeping me really interested into C++ and the developing of C++. So maybe this gave you an idea about what I'm doing with C++, both at the company or at large.
Yeah, I think especially like with this year's Meeting C++, the committee is very interesting because a lot of people are traveling through Berlin to the committee meeting, and some of them actually are giving talks, and like Herb is giving a keynote. And recently at CPPCon, a lot of talk was about reflection and other things with C++ 26. And I've just actually saw that the first features of 26 are becoming available to us.
Yeah, this is a really interesting time right now where we see the very first sketches of what C++ 26 might be, not only in reflection, but also we have implementations in particular for pattern matching And we have implementations for the contracts feature. Companies are very interested in the contracts feature in particular because it plays a big role in making C++ more safe. Now we can actually check that our preconditions and postconditions and also the invariants can be much more thoroughly looked into by the compiler and checked if we are using our own code right, or if a colleague has trouble with understanding what we have done and maybe is falling into a pitfall. And so I really look forward into contracts just as well. In C++20 we had disease, contracts, concepts, coroutines. That was for the third C. That was another C. And now we have the fourth C, and this is contracts. The missing feature from C++20.
We do have a talk on contracts on the conference by
Right.
Team. And we do have a talk on reflection, and also Herb is going to speak on reflection, I think. But then, of course, what are the features you are working on in the committee? What gets you excited?
Well, to be precise, I read every paper, and the most exciting to my taste is the proposals regarding pattern matching, and also I think pattern matching is this stuff that's mostly exciting me, because it makes making decisions in our code and branching in our code based on decisions much more easier. Now we have to resort to if statements or switch statements, but pattern matching is much more versatile. And in particular, if you look at the possibilities we get, for example, with an optional or with a variant, now we don't have to do these kind of clumsy kind of things. Pattern matching makes it much easier. And we can also do the match in expressions also in a regular if. So it's not just the inspect statement or match statement, to be precise, that is actually coming as a new feature. It's also possible to use it in existing branching, like, for example, if statements.
Yeah, there has been a recent blog post on C++26 introspection and Rust comparing the code generation abilities, which isn't pattern matching, but I think that the abilities shown there for pattern matching will be very useful for introspection will be used for pattern matching as well.
Right. So, pattern matching is, I would say, the most end-user friendly feature in C++ that I can see right now. I think it's easy to understand from what it's meant to be, if you don't go overboard, like we usually do. With every new feature, we try to solve everything with this new feature and expect it just to be the same case here with pattern matching. But if you use it in the sane way, I would say pattern matching is something that many people should have a benefit from. And besides pattern matching, safety is something that I'm really interested in. I'm not in the safety study group, but I look at every proposal we have, and
I think with safety, that's a bit an open question at the moment, right? We're still at the very start of defining the standards, so I don't think like stuff on proposals.
We have a couple of things that we have to think about. One thing is, for example, undefined behavior. Many people are not happy to have this notion of undefined behavior in our language. And I belong to this group of people who are not happy about undefined behavior, even though I totally know that the foundation of C++, which is C, is built upon undefined behavior. Maybe I will give a talk about why we actually have undefined behavior in C++, and what does it matter to us, because most people don't really know what the foundations or the origins of undefined behaviors really are. And I'm very happy to see a proposal that makes undefined behavior into something that we can really deal with. For example, we have this new notion about erroneous behavior.
Yeah, that's what I wanted to ask.
Yeah, erroneous behavior, this is something that says, okay, what you do right now, for example, use a variable which you didn't initialize beforehand. This is no longer undefined behavior that it is right now, but it is now in C++26 erroneous behavior, and this means the compilers can no longer take advantage of having undefined behavior in your code. And this is a really, really big deal. Now you can really reason about what you have written in your source code. In many cases, you, for example, test for something, and because of one line of code that may exhibit undefined behavior, the compiler will sniff that out and say, okay, here's a construct that might be undefined behavior, and now free to do everything. And this is what compilers actually do. And now you have these wonderful blog posts or posts in social media where people are totally surprised to see what a deal is the compiler doing right now. I don't understand what's going on there. And this is just a feature that the compilers are really using. If you have undefined behavior, it will do whatever it thinks it can do, because now your whole program is no longer bound by the specification of C++. And this is something I don't like that much. I, as a language person in the committee, have probably fewer troubles not falling into the trap of undefined behavior, but the average developer has barely any chance to avoid it. And I want to make C++ much more palatable to the regular user. We have millions of developers, and we want a language that everybody can understand and can confidently program in. You don't have to resort to the so-called memory-safe languages like, for example, Java or C#. All of these languages are built on the notion that you have a virtual machine where everything is defined in. Now we don't use all these additional means like a virtual machine or what Rust does, extreme serious work of static analysis. No, we want to make our language safe by itself as much as we can, and still be compatible with the past, and still be bare to the metal. This is what we want. This is why we're using C++, and this is why I am using it in our machines. We can't afford big computers built in there for the control or for the data inspection. We need to take as much as possible out of the machine to have performance, response times, and good UI and responsive UI.
Yeah.
And this is why I'm using C++ here.
And I do think that C++26 from today's point of view looks very good in that area, that we add like abilities we never had, like with introspection, and definitely then we'll have to see how it's like the downside from those big features, which we all know, is like the time to have this implemented and then have the implementation be checked against the other implementations and the standard, and that takes time. We just saw it with modules. You talked a lot about modules, and this year we have a talk which, this is about getting started with modules.
Yes,
And
I've rehearsed it last year.
That's a great talk I'm looking forward to. But let's talk a bit about your talk. You also have submitted a talk to the conference, and you're speaking this year about not getting lost in translations.
Yes. It's kind of a snarky title. Some people might be aware of this movie picture, what's it called? Lost in Translation. And I wanted to expand on that. We don't want to get lost in translations. And as we all know, translation is something, a term that is quite overloaded when it comes to, in particular, to computers. Many people think translation, this is something that we might have done at school when we have been speaking foreign languages. But translation is also something that we speak about if we talk about compilers. A compiler in the standard is actually called a translator. It translates between our source code and what we get out of it. And this is the idea behind this talk. I'm speaking about one particular feature in this machine that I've been alluding to a bit earlier, where we have an UI with multiple different UI languages for our customers. For example, we have Swiss customers, and in Switzerland, we have German, Italian, and French. And each factory floor worker wants to see UI in the native language that he feels confident in, and wants to change the UI during the runtime of the inspection system. And this is a core feature we have in our code. And unfortunately, 2 years ago or so, we had a proposal where our string output can no longer be translated at runtime, as we have been using it 10 years in the past. But now we have to do as much as possible at compile time. And compile time is something that is also a translation in a particular subsystem of the compiler. And so I had to find an implementation of all this stuff that's in there that executes within the compiler, uses all the constant evaluation features we have now to build a system that can later be used in translating our output strings to the UI, but still keeping all the benefits of checking as much as possible at compile time, so that we have the confidence if our code compiles, it will run in the end. This is something that we have been experiencing before. For example, a customer has made a translation of a particular output string, and there was an error in there, for example, for the formatting of a value. And in the past 10 years, we had an exception by that. What means an exception in a system? You have to deal with the exception that has been thrown by the output. And how do you deal with that? Yeah, there is little you can do. The best thing you can do is to say, okay, here's a problem. I bring this machine in a safe state, but what you have done so far is lost. And this is not something that our customers want to see. So doing things at compile time, so the translation at compile time, is something that is really beneficial for our customers and for us as well, because we now can be sure that whatever we translate, whatever we have in our source code, is okay if it passes the compilation. And all of this, all the different aspects of that are part of the talk that I will be giving here in about a month's time or so.
44 days, it's today.
44 days, yeah.
That's a very short time. So if you want to be lost in translations and see her talk, we see us in Berlin with everyone else. So I know that this talk has been a keynote at a different conference, I think CPP on C.
Yes.
And
unfortunately, this was not one of my best talks. I was sick that day and the days before, so
okay.
I hope the talk at your conference will be better.
Oh, for sure. That's Herb has practiced his keynote too at CPPCon, so and lots of people practice their talks so that they can give the better version at my conference, which I value. And let's move away from your talk again. It's going to be an interesting talk, but it's probably not that interesting to keep talking about forever. What is then of all this, what you're working on, getting you excited in C++ right now? So with all the translation talk at compile time, I suppose you use STD string at compile time?
I use std_string at compile time. I use std_vector at compile time, but you can do many things. Const expr has grown so much over the past 10 years, that we can pretty much do everything at compile time. And there is one thing that is complicated or to some degree impossible to do at compile time, and this is allocations. For example, if you have a std_string, allocates to store the string value, at least if you have something that is larger than the short string optimization that we have in std_string. But if you have an allocation, the same is true for vector, then you can't persist the contents of your string or your vector to the runtime.
Yeah.
This is something that you can do with string view. String view can be constructed at compile time. It does not allocate. So if you find a way to allocate your stuff as much as possible and not put it into a vector, you can persist it to runtime.
That is true. You pay a compile time cost to save your results, and especially if it's strings, then you have to put those into constant chars.
Yeah, you have to do this anyway, because if you want to translate your strings, for example, using the getText utilities, maybe many people are aware of the getText utilities, the original string needs to be a string literal. So you have it there. So there's no need to actually introduce new allocations or literals or whatever you need to have. You already have it. Then you have to manipulate these string views into that.
That's actually something that I could ask you about, a feature which I've recently learned about. It's like in out pointer, which enables you to, give certain pointers to C APIs, which then seem to be behaving in a certain way. Are you making use of that?
No, I'm not using these kind of features. I actually wouldn't use it anyway. I have a better feature. This is what I've been showing 2 years ago at the keynote at CPPCon and your conference. I had a improved version on that makes using C APIs much, much easier. And what, alluding back to what you said a couple of minutes ago, we don't have reflection or introspection in C++. This is not true. We actually had it for a long time. We have it since C++ 11. And we have it in the standard. The standard library, one of the include files in the standard library is the type traits. And type traits are an inspection into your code. And you can use that.
That's true, but it's very limited.
It is, yeah, you can do many, many, many things.
But
if you
inspection that is coming, you can read the result from the compiler back into your code. As far as I understand, you can access classes
yes,
and create classes. So,
for example, if you want to know if a particular member or a particular type is in your class, you could do it at C++ 11, but it was tedious, and you had to do a lot of template metaprogramming.
Thanks. But I like that it's becoming more available and easier to use.
Absolutely. I have one slide in my talk where I will show how this would look like, what I'm trying to achieve there if we had C++ 26, but unfortunately we don't. And I think if we have compilers in production quality that actually implements all of that, it will be, I would say, 28, 29, something like that. This is the time frame when C++ 26 is out. It's published, it's grokked by the compiler implementers. We have ironed out all the bugs in the implementations and can use it, for example, in an industrial environment. We no longer speak about toy examples. What we see today in the implementation is in many cases just toy examples, but we want to have production-ready code. So we need to be a little bit behind the curve if we want to put something into our machines or into our cars or whatever it is where our C++ code lives.
Yeah, it's true. And I see that a lot of people are still working with C++ 17 in their everyday jobs.
Right.
And moving to C++ 20 just becomes available with the newer generation of compilers.
There's a good reason for that. If you look at the latest version of MISRA rules, and this is an industrial standard, automotive.
Totally, yes. Autos are MISRA, C++ 14, 17.
All of them
not have a choice.
Are stuck at C++ 17 because this is what MISRA 23 is talking about. So many people who are looking into C++ 20 still can't use it just because of the regulations that are behind C++. Many people say, oh, let's get rid of all of that, but then we no longer can use C++. Many industries use C++ in a way where we have to follow the rules that are put upon us.
Yeah, I do wonder how many of us have to live under the rules of MISRA and are not free to move on to a newer standard.
We have the freedom to use whatever we want, but yeah, if you are in the car industry or the medical industry, things are completely different.
Which is understandable. I do think that MISRA, etc. is a very good thing to have. And on the other hand, it's very interesting to see how they react when you want to do something open source with them. Because
right.
It's a very commercial ecosystem.
As far as I see, there's even a keynote at your conference about one of the collaborators in MISRA.
Yeah, it's true. Peter Sommerlath.
Right.
He speak, and maybe he mentions MISRA in his keynote. It's actually like a unique opportunity. The keynotes this year actually have descriptions, which is rare. 3 of them. Hannah Lucy cover. I think we'll talk about containers if I was right, and something also constant expression, etc. But she hasn't given me a description, and that's fine because she kind of is still in flight with things and just doing things. And I think with keynotes, the problem of giving a keynote description is that people might misunderstand it, or that the keynote speakers might choose to go in a different direction. So I was quite surprised when every keynote speaker except Hannah, who has maybe a bit more experience, gave me like complete descriptions of their keynotes. And I think we have a very nice span from the opening keynote with Titus Winters to the closing keynote.
Yeah, I'm really looking forward to watching these keynotes. Even though I think I know what Herb will be presenting, everything is on this on a what let me say. We want a safer, better usable C++, and I think all of these keynotes play on the tune, each in their own sound, but they all play on the same tune, so they make a lot of sense to have all of them at the conference to give you the full picture about what's going on in C++.
Yeah, I was looking for keynote speakers that have a connection to the committee, and that's true for all of them. And I'm very much happy with the keynotes we have this year. Very much looking forward to
Titus
it.
is no longer at the committee.
Oh, that's the great thing about it. He was, but now he can say now he's. I mean, he was at Google, had a lot of. I was looking for someone actually like an opening keynote speaker, and I choose Titus because specifically he has experience with the folks in the committee. He has been a part of it. He has moved from Google to Adobe, and so he can speak openly about
Interesting.
What is on his mind. So generally I choose speakers, and then they can decide what they want to keynote on. So none of them have to, make a keynote about the committee, which I hope nobody ever does. It would be, but I think the work of the committee is quite interesting, and as you said, I guess the overspanning theme, which one can see.
Yeah. Titus is really experienced. He, with his background at Google and dealing with code bases, that are really huge. And now we are back to the idea about we want to make C++ more safe for all the millions of developers. And thinking about what he has been speaking about in the past, this is an interesting topic. We are a small company. We're just 2 developers right now. And I see how difficult it is to bring my input from the committee to our team. And Titus can speak about bringing the idea of the committee to thousands of developers. And what does that mean, and how you make sure that your code base is consistent with all this diversity in the teams that you have. So now this is really interesting to see. I'm looking forward to what he speaks to us. Now you say he's at Adobe.
Yes.
Of the other big thing that's coming from Adobe and ST Labs as far as the.
I know that not Herb's working for Microsoft, but Sean Parent, a lot of other interesting people work at Adobe.
Abrams.
Dave Abrahams. We have a speaker from Adobe also who's speaking about the Beeman project.
David Sanker, yeah.
Yeah, David Sanker, right. And so...
Yeah, but at this particular group of people that we have been mentioning right now is working on the Hilo language. Maybe you heard about it. One of the influences that we may possibly, I don't know, incorporate into C++ in some way. We have Safe C++, we have Hilo, and we have the people who are working on that.
I believe that I also help with CPP2 and all those ideas as a very interesting, very, very open community, which is in contact with each other. And I believe that a lot of those ideas will come to C++ when it's feasible to do that in C++.
And this is what I really want to see.
Yeah.
We have different venues to that. If you look at the Safe C++ proposal, this is pretty much Rust-like with the borrow checker in there and the lifetime annotations. If you have seen the syntax of Safer C++, you will notice it may be foreign to many, many people who have been developing in C++, for example, for 10 or 20 years. And now the syntax would change so much. This may be difficult.
Matching that will be true with all those big additions which need to establish new expressions and do things which are not constant expression. The introspection post, which was out this week, comparing Rust and the C++ reflection proposal, it's the same. And of course, there is, I think, a competition for syntaxes and generally, probably not keywords, but like, short forms, like what does a certain sign, which is currently not reserved in C++, like, can we use a $sign? Can we, switch context here? It's an interesting time to see what is coming, maybe.
Yeah, but the different other venue that is coming, and I see a lot of merit in it. This is what the idea that's in Hilo. Hilo makes the language much, much safer, or makes it a safe language by looking at the fundamentals, and which is what we already have in C and C++. And this is, we speak about values. Many other languages speak about more reference-oriented approaches. This is safe if you have a virtual machine or a garbage collector or this kind of stuff. But if you don't have that, like we don't have them in C++ or C, then values are much more important. And if we just get rid of much of the references we have right now and the pointers, now we are left with values. And Hilo is a language that speaks about values. And this is much more natural to C++, in my opinion. The syntax is very natural, in many cases just the same as we had it before. And if we do, we want to improve the speed, for example, to put function parameters. If you want to transport a value over the boundary into a function, nowadays we say, okay, this is a reference, and this makes it unsafe. But if you say it to the compiler, okay, you get a value, but this is an in value, or this is an in-out value. Now the compiler can look at it behind the scenes and still generate code to make it a reference. So you get safety of values with the performance of reference parsing.
on the weekend, I tried to understand what forward like is for, and Jason Turner, just the newest C++ Weekly, is about forward like. I really liked how this aligned. I was like, that's great. Jason explained that to me, and it's actually a tiny thing which you will need when you implement this feature, and then you can have a value be returned in the same type it was given to you, but in a generic way. But you have to watch the video. I can't explain it as good as.
Yeah, you're probably speaking about functional assignment and this kind of stuff.
Where you can.
You can optimize a lot of things if you.
With deducing this, you can implement a getter. He showed a getter as an example.
Yeah.
You can implement a getter, which is one function and works for constant, non-constant R value and L value combinations.
Because the specifiers are actually.
Yes. Then you use forward like to make the return of the type you have been given.
Right.
Correct.
Yeah, but it is to some degree, it's a kind of deduction, what you have in templates, but on steroids.
Mm.
You can.
It's a detail. To me, it's a detail. It's like forward like is not something that you will use every day, everywhere, but with deducing this, which actually is also in GCC 14, because I'm thinking about switching or updating to GCC 14. I was like wondering, what do I get from that in terms
not
of?
much. My experience is it was touted as a big feature, and it's really stunning to see what you can do with it. But barely found any use cases where I could use it. This is my experience. Yours may be completely different.
I have worked a lot with CRTP, and now I could be using this for CRTP, because I think that's also one of the big use cases for CRTP.
This is a different use case, and actually it makes it much easier because now you don't need to derive from templates anymore.
Yeah.
This is one of the benefits of the explicit objects.
Yeah. Explicit this and other things. It's really interesting. But I think with that, is there anything else you have on your mind for C++ you want to talk about?
I don't think I have anything else. What's really interesting me, this is something we have been speaking about, making the language safer and making the language more regular, make the language more approachable, have confidence in working with it. This is something that I have on my mind.
Yeah, that's a good thing to work on, and will keep you motivated for many years.
Yeah, I think
Thank
so.
you for your time. I enjoyed very much this. And now we're already at 40 minutes, so I think we'll close it here. Thank you. The time has gone by.
Time is flying. Yeah, okay. Thank you for having me.
You're welcome. Looking forward to see you in Berlin.
I'm looking forward to see all the nice people and from all the participants and people who are watching here, and to meet you all. It's every time a great experience to come to Berlin to the conference.
Yes.
And conference life is completely different to blog posts or YouTube videos. Or come.
If you're able to make it to Berlin, you should. I agree. And otherwise, there are online tickets available to watch the stream. I've recently re-implemented the time zone support, so you're actually able to see in the schedule and the live schedule, because the other schedule is a static website and can't do that. But in the in that schedule, you actually can switch to your time zone and see that Hofstadter speaks at what time in your time zone in the keynote or other talks. Also, that gives you access after the conference to watch the recordings. And I'm very happy, like I've already sold an online ticket to Australia, and it's not everyone can come from Australia to Berlin. But I remember 10 years ago, the t-shirt I'm wearing, first time in Berlin, and we had someone fly in from South Korea.
It was my very first Meeting C++ conference as well. And 10 years, well, I like it to be there.
Well, 10 years in Berlin, that's true. We'll celebrate that. Anyways, thank you for your time, and we'll see us in Berlin.